Hello everyone, welcome back. Let us continue the problematic part. Let us see what is the given data. A soil sample is subjected to the hydrostatic pressure sigma. The Mohr circle for any point in the soil sample would be. A soil sample is subjected to the hydrostatic pressure sigma. The Mohr circle for any point in the soil sample would be. So if you remember, the same point you guys might have studied in the strength of materials. If it is a hydrostatic pressure, there won't be any shear stress at all. If there won't be any shear stress, there won't be any circle will form. That means definitely there will be a point that will be lying along the x-axis. So what is the correct probable answer? Mohr circle is nothing but a point at a distance of sigma from the origin. So option C is the correct one. So this is the question they had again asked in 2017. Move on to the next. In a consolidated undrained triaxial test. So here we are talking about the CD test. The pore water pressure is 0. Now can you guess where the pore water pressure will be equal to 0? So this is the question they have asked in the 2016. So if you remember, the pore water pressure will be equal to 0 at the end of consolidation stage only. So after that, the pore water pressure is 0. Move on to the next. A drained triaxial test. So this is the question given in the year 2016 for 2 marks. Now let us first understand the question. What is the given data? A drained triaxial compression test on a saturated clay yielded the effective shear strength parameters are given. It is a CD test, cell pressure is given, pore water pressure is given. So what they're asking? They're asking us to find out the deviated stress. Can you find it or not? C dash given, phi dash given. Cell pressure means C3 value is given 200 kilopascal. Pore water pressure is also given 150 kilopascal. So it is a direct question, that is you can use sigma 1 dash nothing but a sigma 3 dash into tan square of 45 plus 5 by 2 plus 2c dash into tan of 45 plus 5 dash by 2. That's it. From this you will get it on the sigma dash, and based on that you can find out the sigma d. Just you have to substitute the calculation part. Then you will get this value as around 104.36. Okay. Let us continue the problematic in the next class. Thank you.